Rolle's theorem. Given that f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, if f of a is equal to f of b, then there is at least one number c in the open interval from a to b such that f prime of c is equal to 0. Let's take a look at an example of how Rolle's theorem would be applied in a problem. Let's consider f of x equals x squared minus 3x plus 2. We wish to show that f prime of x is equal to 0 at some point between our two x-intercepts. We know that we have two x-intercepts because this is a quadratic equation with two real solutions. It can be factored as x minus 2 times x minus 1. And if we take each factor and set it equal to 0, we have x minus 2 equals 0 and x minus 1 equals 0. In other words, x is equal to 2 and x is equal to 1. Therefore, we can say that f of 1 is equal to f of 2, which is equal to 0, which satisfies one of the necessary conditions for Rolle's theorem, and lets us know that there is at least one c on our open interval between 1 and 2, such that f prime of c is equal to 0. Now to find that value, we take the first derivative, so we have f prime of x is equal to 2x minus 3. We set this equation equal to 0 and solve for x. So 2x minus 3 equals 0 would yield x equals 3 over 2. And this value lies in the open interval from 1 to 2, thus illustrating Rolle's theorem. This concludes our example. I hope you found it helpful, and we'll see you next time.